uh, as you see that different type of crystals, when they occur in nature, they have some shapes, and if during the process of crystallization these shapes are preserved, so we use different terminology. And normally geologists, they like to throw new terms, especially the western geologists. They use so many terms, and sometimes it is very confusing for someone who tries to learn a new subject. So he ends up with having so many terms, but all credit goes to the author Mackenzie for summing up the terminology and summing up the terms that we use for description of rocks, especially igneous rocks for this case. So here you can see crystal shapes that are related to different mineral. So normally there are two types of terms that are used for crystal shape. One are those that are relating to the quality of the development of faces, and the other that specify the 3D shape of individual crystals. So the first one we will see is the quality of how different faces are developed in particular minerals. So the terms that are normally used, and then we will see the example of each term one by one. So here we have the first one is euhedral. So as the name indicates, euhedral, we will first see the meaning and then we will see the synonyms for that. The euhedral means that crystals are completely bounded by its characteristic faces. It means that you will find the characteristic boundaries of a crystal in a thin section, then you can call that as euhedral. Similarly, there is another term, subhedral. Subhedral implies that crystals bounded by only some of its characteristics. Okay, we have another term, subhedral. That means that there are some of the crystals that have characteristic features, and anhedral means that there is hardly any crystal face that is present. So now we will see the terms that are synonym for euhedral. Sometimes some petrographer, they call it as idiomorphic or automorphic. So these are two terms that are used for euhedral. Similarly, there are some terms that are used for subhedral, that is epidiomorphic or hypetomorphic. And then comes the anhedral. So we have allotriomorphic or xenomorphic. But remember, mostly in literature, you will find these terms and these terms. So these terms are, I haven't seen them much except for this one, xenomorphic. So mostly in literature, if you read idiomorphic, it means euhedral. Epidiomorphic, it means subhedral. And allotriomorphic, it means anhedral. So these are the terms that are normally used to describe like how well the crystal shapes of a crystal are developed in a particular thin section. So here what we have a euhedral olivine in olivine basalt. So you can see beautiful, interesting faces of the crystal, and you see a very good shape of it. All the faces are very well developed, as you all guys can see. So this photograph actually shows you an olivine, and so you can see the prism shape of this olivine. and you can see relatively finer grain matrix, and there are some elongated crystals that are present. Could be the plagioclase feldspar. As you can see, the white and black lines that are present on these crystals. So this is an example from an olivine basalt from Western Greenland, and the view is cross polarized. So you can see characteristic feature of olivine is the fracture orientation that is present within this crystal. Now we see the other example that we have for this topic. We have the subhedral olivine that is present in picritic basalt. So some of the faces on this equidimensional, so you see some of the faces are preserved, however others are curved or embayed. So you see this is a embayed crystal surface and this is the curved crystal surface. So it has two crystal characteristic features, surfaces that are indicator of olivine. So it means this is an example of subhedral olivine, or what we call the epidiomorphic olivine. So this example is also from the Western Greenland, and the view is cross-polarized. Then comes the anhedral olivine Phenocrysts in basalt. So what you see, you don't see any crystals face of olivine that we have seen, like there is curved boundaries, some embayed boundaries, but there is no crystal face of that particular mineral. So you can see that most of this olivine has an as a shape that is having no crystal faces. So you can see the brown margin or the perimeter of the olivine, that is due to the oxidation and hydration, and the crystals that are present inside is olivine, and then we have the in eating site is a mineral. So that is actually formed by hydration and oxidation of olivine. So it is from the Indian Ocean, Mauritius, and it is an olivine basalt. So let's see what we have for the three-dimensional crystal surfaces or shapes. So in the three-dimensional, the terms that indicate the 3D crystal shape. So there are some general terms that includes. So sometime if you have a very coarse grained rock, you can also see the 3D shape of some of the crystals, especially if you have a granite or especially if you have a gabbro. Sometime you can see beautiful 3D faces. The example is sometimes garnet. It's very coarse grained, and also some of the gemstones. They are like larger crystals, so you can actually see the 3D crystal shapes on that. So there are some terms that are used for 3D. That is equant, polyhedral, equate, anhedral, and spherical. So spherical means that how near it is to a sphere. Equate anhedral means that it almost have the same size, but there is no crystal surface present. It is almost the sides of the crystals are having the same dimensions, but the thing is that there are no crystal surfaces present. However, equant polyhedral means that it is almost the size is the same, and as well all of the surfaces and all of the are well present. So he has mentioned that sometime grain and granule are often used for equidimensional crystals. Sometime if we have equidimensional crystal, we also call it as uh, grain or granule. And sometimes if it is smaller than that, we also call it as drop or blip. So these are the terms that are normally coined for these type of deposits. So then we have examples for in equidimensional shapes. So sometimes the dimensions of the crystals are not equal. You see that for example, for this crystal, you see that there are three different dimensions that are present. So for them, we use different terms like tabular, laminar, plated, columnar, and acicular. So these are some of the terminologies that are used specifically for the 3D description of some of the minerals. Like for example, he has quoted an example of bladed feldspar like this one. So the 3D shape will be look like this, but of course in the thin section you will just see the one side of it. Okay. So he mentioned that sometimes these type of bladed crystals in the feldspar are called the laths or lath shaped feldspars. So these are some of the examples, and you can use these terms, and you will see these terms coming up. अगर आप future में use करते हैं microscopy, petrography for your higher degrees, even if you want to do your masters or your PhD. So you will see these type of terms even if you are doing cements in sedimentary rocks, and if you are doing the description of sedimentary rock as well. So terminology almost remain the same, especially the euhedral, subhedral, and anhedral, because they indicate the transportation. If the sediments are transported very near to the source, then the chances are there that it will have anhedral shape because it has to be transported, and if it is transported to very far, then chances are there that the sediments are euhedral. So I guess आज हमारी जो मीटिंग थी वो already scheduled थी for 30 minutes. So if the meeting ends and you have any questions, so we can share another link and you guys can just join in if you want to have any question. If this meeting ends or if this meeting continues, so we can just continue. So I open if you guys have any question, so we can discuss.
सर जी
Yes.
वो इक्वेंट वो सर पॉलीहेड्रल का दोबारा बता दें इन दोनों तीन टाइप्स की दोबारा स्फेरिकल वाला.
Okay. So we go again.
Yes, sir.
Okay. So this is all that we talk about is 2D. इसमें you don't see the third dimension of the crystals, right? Similarly, in this one, you all just see the 2 dimensions and you don't see the Z axis for that. However, जब हम 3D की बात करते हैं, तो there are some terms that are used. If you can see the crystals, especially if the crystal size is large enough to understand the 3D shape, especially जब आप gemstones को देखते हैं या आप देखते हैं किसी जगह पे अगर आपके पास कोई garnet crystals हैं, so those garnet crystals will be large enough. Sometimes you can see the shape of these minerals having typical surfaces. So polyhedral means that this one is having more than one surface that is present. So we have more or less the shape of the crystal is having almost the same size, like if you see this dimension and if you see this dimension and if you see this dimension, and all of these have a typical style of what you call the typical surfaces, very clean surfaces. So it shows how cooling was happening in the magma chamber. The cooling process was slow, so that it allowed the development of all the faces. Similarly, if you see the equant anhedral, so the difference between these two is that in this example, we don't have the development of crystal surfaces, and the crystal shape is not well defined. Maybe it is result कि यहाँ पर हो सकता है कूलिंग का प्रोसेस जो था वो बहुत जल्दी से हो गया, जिसकी वजह से कोई क्रिस्टल फेस ही डेवलप नहीं हो सका. So this is an example of equant anhedral. So these are the terms
Yes, sir.
that are sometimes used to describe the rock into 3D.